Okay, so like I was saying, I wanted to review with you some of the things about position time graphs. And so you might want to take notes on this. Okay, so first of all, the vertical axis is position, the horizontal axis is time. And for our position time curves, we might have one that looks kind of like this. Okay, so okay, and so here's one of the ways you can think about this. Okay, we're going to make roughly equal time intervals here on the horizontal axis. And we see that the first point might be up here, then here, then here, whoops, and then here, and then here. Okay, and so notice I'm going to draw steps. Let me try this again. There we go. So there's a step. Try that again. Wow, I'm having a tough time here. That's better. I'm sure it's going to let me follow the straight lines in there. There. Okay. So, okay. So the object is changing its position. It's moving from position 1 to position 2 to position 3 to position 4 to position 5. And each time that it moves, we see that the change in the position is getting smaller and smaller. And what I mean by that is that if we think of this as a series of steps, right, the steps are becoming shallower and shallower, right? The vertical distance of the step is getting smaller and smaller, right? So this vertical distance here is smaller than the previous one. And then the next delta P is getting even smaller. So since the delta P's are getting smaller, that means that the object is slowing down. Right? And we can say that that's because delta P is getting smaller. Okay, so it's slowing down. Now, the other thing I want you to notice about this particular graph is that the object is changing its position from 1 to 2 to 3 to 4, which is moving on the graph, it's moving down. Now, what that means is that it is moving to the left. Okay, so this first graph is moving down and moving to the left. Okay, so let's draw another one, another position time graph. Okay, position is on the vertical axis, time is on the horizontal axis. Okay, so the next graph, perhaps the next graph can look like this. Okay, and so once again, we are going to draw equal time intervals. And we're going to see what happens at each of those time intervals. Okay, so here's position 1, position 2, position 3, and position 4. Whoops. Position 4. And so, first of all, right away, we can see that as time moves on, we're moving from position 1 to position 2 to position 3 to position 4. And again, that means that the position value is decreasing. And so that means that it is moving to the left. Okay, so now let's draw in our steps. And if we went one position further, to say position 5, I'm not going to do that. Okay, all right, so now here you should be noticing that the delta P is starting off small, and when I say delta P, that's the vertical change on this graph. Okay, so that's the vertical change on this graph. And what you should be noticing is that the delta P in this instance is increasing. More room. Okay, since the delta P is increasing, then that means that the object is speeding up. So that means that this graph corresponds to a situation where the object is speeding up and it is moving to the left. Okay, so if you can draw in your steps like this, and the object and the vertical step is increasing in size, that means that the object is speeding up. Okay, here's another graph. Vertical axis again is position, the horizontal axis is time. Okay, and perhaps the graph looks like this. So once again, we want equal time intervals. And if we draw in our steps, goes like this. Okay, and in this case, you should see that the delta P's, right? Again, the vertical parts are the delta P's. Okay, change in position. Okay, so the change in position in this situation also, delta P is increasing. Delta P is increasing, which means that it is speeding up. But in this case, we notice that these points it's moving from point 1 to point 2 to point 3 to point 4 to point 5. Okay, and so those points are moving up on the position time graph, which means that the object is moving to the right. Okay, and so, okay, let me look back and just recollect which ones we've done. Okay, so then our fourth graph is going to look like this. So again, we have position and time. Okay, and this time the graph will look like this. Okay, and we're going to want equal time intervals again. Okay, so that's point 5. Okay, so as the object is moving, it moves from point 1 to point 2 to point 3 to point 4 to point 5, which means that it's moving this way. That means it's moving to the right. But hopefully you notice that the delta P's in this case are decreasing. So in this case, the delta P's are decreasing, which means that the object is slowing down. Okay, so we have these 4 graphs so far. The one where it's curling down to the right. And so this one is also curling down to the right, but one of them is like a bowl, right? And then the other one is like an upside down bowl. Okay, and then this one is curling up to the right, but then this one is the upside down image of that curling up to the right. Okay, so you need to know how each of those graphs depicts the motion of the object, whether it's moving to the right or to the left, and whether it's speeding up or slowing down. Okay, there are 3 more graphs that you have to know, position time graphs. Let me try to fit them all in on this one page. So position and time. Okay, so one of them goes like this, one goes like this, and the other one goes like that. Okay, this one is moving to the right. As it's going that way. Okay, but it is at constant speed. Okay, this one is going this way, so it's moving left. Also at constant speed. And this one is not moving. So therefore we can say that it is at rest. Okay, so you need to know how to match the position time graph with a description of the motion of the object. Okay, so again, just to look at this really quickly, when it's sloping down to the right, and it's kind of a U-shaped thing. Okay, then that means that it's slowing down, moving to the left. When it's an upside down U, but sloping down to the right, that means it's speeding up, but moving to the left. Okay, when it is sloping up to the right, and it's a U, that means it's speeding up and moving to the right. But when it is like an upside down U, but moving up to the right, it's slowing down and moving to the right. And then we have these three, which the object is moving at constant speed. All right, so I'm hoping that all of this